So as we work today into different types of patterns, so far the ones we worked with, what have we been doing? How many, when we were working with that, how many circles are in a certain box number? What have they all been so far? Sylvia?
1, 2, 3.
And what are we, yeah, and we've been multiplying by those numbers, haven't we? It's been n times something to get the total number of circles. Okay, so here's what we're going to be doing today. First of all, we are going to take a pattern that is going on and we're going to transfer it to a table, okay? So we're going to take this number 1 here in box 1, we'll put the 1 here, and the number of circles, we'll count up how many circles there are and put that in our number of circles area. So how many are there?
4.
4. Okay, go ahead and fill out that table. You can do this by yourself. You can count. Okay, do we all have a filled out table? Okay, so now let's do this. We're going to analyze what's going on here. So how do we get to the number of circles is basically what it is. So we are going to have equals 4. It starts with 1. So what are we going to have to do to get to 4? It starts with 2, and we have to get to 5. Go ahead and fill these in like I am. It starts at 3 and it has to end up at 6. We have 4, that has to end up at 7. And 5, that has to end up at 8. I'm thinking that maybe it's not multiplication this time. You think, Wade?
Adding 3.
You think it's what?
Adding 3.
Adding 3. Is that going to work? You think what? Sylvia? It's adding 1. Okay, so let's check and see who's right here. 1 plus 3 is 4. Is 1 plus 1 4? No. So we're going to have to maybe try Wade. 1 plus 3 is 4. Well, then we have to see if that'll work all the way through. 2 plus 3, does that one work? 3 plus 3, does that one work?
Yes.
4 plus 3?
Yes.
Oh, and 5 plus 3?
Yeah.
Okay. So now we have to write the algebraic pattern for that. Because it says, analyze the pattern in the table, that's what we just did, and write the algebraic pattern. In other words, no matter which box you were looking at, you would be able to use the pattern and be able to tell how many circles should be in it. So I need a C in my pattern and I need an N. Wait.
C equals n plus 3.
C equals, the number of circles equals, take the box number and add 3. Does that work, class? Were we adding 3 to the box number? We were, weren't we? Heck yeah. How did you want to write it? Is there another way we could write it? Could we do what? Okay, could we write it n plus 3 equals C? Yeah, we could do that. We could write n plus 3 equals C. Could we write 3 plus n equals C? Yes, because addition allows the n and the 3 to trade places. So there is more than one way to write this. Okay, now it says how many circles are in the 10th box. So we are going to, here's what I want first. I want us to write down our algebraic pattern. Write that down. And now we're going to substitute in, just like we were doing in our warm-up exercise, they say in the 10th box. So what is that 10? Is that our C or is that our N? That's our N. Remember, the box number is our N. So we are going to put 10 in for N. And that should tell us how many circles would be in the 10th box. How many circles would there be in the 10th box? 13.
circles. Okay, 13 circles in box 10. So we're gonna circle two things though. We're gonna circle our, oopsie, not that one, sorry. We're gonna circle our algebraic pattern we wrote back up here. Because we have two answers for this problem. What's the algebraic pattern? And then they wanted to know, well then now that you know the algebraic pattern, tell us without having to draw box 6, box 7, box 8, box 9, and box 10, how can you take a shortcut and find how many circles would be in it? Questions? Okay, then why don't you start filling out the next table for number 2. Start filling out the table for number 2. And then I'll take a volunteer to fill out the rest of my table. I got you started, but I'm feeling kind of lazy. I don't want to do the other part. Sarah, you want to help? Yeah. You can bring your paper if you need to. Okay, thank you. Any challenges? Okay. Then why don't you start seeing if you can figure out what do you have to do to the box number to get the number of circles. Let's write that part down. Let's get ourselves started here. What are we going to do to that box number to get the total number of circles?
Something on your screen.
My Smartboard software has been kind of acting up, so hopefully we'll be all right here. Okay, who can tell me what we have to do? Jen, did you have a hand up? Or were you just going to tell me about the same thing Derek was? No. Add 4? Okay, so if we add 4 every time, is every statement true? It has to make every statement true. Does it? Yes, no challenges there? Okay. Okay, you are so good, you're going to write the algebraic pattern for this now. What's the algebraic pattern for this one? Write it down. Anybody want to put yours up there for me? Thank you.
Right.
Thank you. So Levi says that the algebraic pattern is C equals n plus 4. Any challenges? C equals n plus 4. Could it be n plus 4 equals C?
Yeah.
Okay. Could it be 4 plus n equals C?
Yeah.
Yeah. Could it be C equals 4 plus n? As long as we're showing that we're adding 4 to the box number on one side and the number of circles on the other side. Okay, go ahead and find out how many circles would be in the 20th box. You can either choose to draw all the boxes till you get to 20, or you can take a shortcut. You decide. Sammy, you have an answer? Come on up and show orientation by telling what that means. Okay, challenges. How are we feeling? Sammy's right? Are there 24, would there be 24 circles in the 20th box? Anybody, draw it all the way out, check this out. Can we draw out 15 more boxes? Oh my goodness, wouldn't that take a while? Wasn't this pretty quick to be able to do it? Yeah? Okay, so the final answer here is this one, and we want to circle this one in our notes also. We agree with the algebraic pattern that Levi wrote. We agree with the answer that Sammy got for the 20th box and how many circles we have in it. Okay, let's go to the back side then. Start filling out the table. Let's practice a couple more. Start filling out the table first of all, that'll help. Let's find the pattern. Derek, do you want to go finish filling out the table?
Sure.
Thanks. Thanks, sir. Any challenges? No challenges, or is anybody else done? Okay. Well, some of you are kind of busy yet. Either you're still doing yours or you're already trying to figure out the pattern. Do we know the pattern? You know the algebraic pattern already? Okay. Caden?
C equals n plus 10
And what?
plus 10.
Plus 10. Okay. Now let's check them out and see if that pattern works. Then 11 should equal 1 plus 10. True or false?
Yeah, true.
Okay. Then 12 should equal 2 plus 10. True or false? True? Okay. Then 13 should equal 3 plus 10. True or false? True. And we're going to show for all 5 of them because trust me, there are some more, even more complex patterns that it might change as it goes along. So we're going to say, does 14 equal the box number 4 plus 10? Yes, okay. Does the number of circles 15C equal the box number plus 10?
Yeah.
Yes, okay, so we have a good algebraic pattern. We're going to circle that. Well, I certainly am happy that we have a way to take a shortcut this time. Why? What's our n value? 100. Do you want to draw 95 more boxes with all those circles? No. So what do we show for work now? C equals our algebraic pattern, n plus 10. C equals 100 plus 10. So that means there is how many circles in that box? 110 circles in box 100. First of all, that would be a whole lot of boxes to draw, and that's a whole lot of circles besides. And keeping track, isn't it? Okay, I want you to do the last one, and then you find someone else to compare with. Or I should say, at least 2 other people to compare with. And
You call them on if they're not showing enough work. You challenge them if they have the wrong answer anywhere. Gently challenge them. So how about you just do it with your, at least with your table partner, and then find one other person after they're done. Is there a shortcut to counting up all the circles in a box? Is there a shortcut to that instead of having to go 1, 2, 3, 4, 5, 6, 7, 8, 9? What is it, Pikey?
Count by fives, yeah, could you count by fives and maybe do some multiplication even? Got 1, 2, 3, 4 rows of 5, 4 times 5 is 20, and then we got that one spare one there, which is 21, okay. And then you look at the picture and you see what's happening each time. The number of circles is going up by how much? 1 each time. 1 is being added to that bottom row each time, isn't it? So we don't have to count every single one of them. Okay? Again, after you have your work shown, you know what I mean by work, justify that your algebraic pattern works. Then you go find somebody, 2 other people, but don't bug them if they're not done yet. So you're checking on everything, call them on all eyes. I think some people better make sure you're checking to that they're doing what again? Showing work, okay. Have I shown work yet? Have I shown some of my work? Yeah? I'm super glad I don't have to draw out all these boxes this time. Still working for you, huh? Okay. Any questions? Do you know how much you need to show for these? You know how much work you need to show? Yeah, okay. So am I gonna stamp papers tomorrow without it?
No.
Am I gonna let you finish it while we're correcting tomorrow?
No.
Then being generous in that area too, okay? So anybody have questions about that? Okay, I'm going to stop mine because I asked you to check with at least your table partner and one other person, right? Did you do that?